initially what happened, it is at a certain position, and these are long rails. These are the long rails. These are long rails. Now what will happen and there's a resistor. In place of resistor, you connect a bulb or a heater coil. Anything, it can be that one, which will consume electric power. This is what the resistors are. For the rod PQ open, I'll project with a rod. I'll project this rod PQ with a velocity U. A T equals it and release it. And then he's asking all the things. Find the expression for induced current, speed of the rod at any time, and total heat generated in the resistor. There's no resistance for this conducting rail. Similar to railway track is what you should assume here. And the B bar is uniform. B bar, there's a first problem. Please first try to understand, because all the numericals are related to this diagram only. B bar into the plane or out of the plane. Rod given velocity towards left, towards right. There's no resistance of the conducting rails. Time being, we'll assume that no resistance. Then let's first apply the Lenz's law. Flux negative. And as the rod moves, as the rod shifts towards right, negative flux increases. d phi by dt, negative. EMF induced will be positive. So how the induced current should flow now? Induced current in the rod should flow in anti-clockwise. Now, moving rod we used to replace with a cell. So here I'm bringing a cell. Now, sir, you didn't give any cell. Suddenly you brought it. So what is the basic idea? A moving rod will behave like a source of EMF. A moving rod will behave like a source of EMF. There's a motional EMF, that one. So I'm writing V also nearby it. Then what is the expression for current now? I equal to E by R. Now suddenly from in place of rod, what has come? The cell. So this you write it rod only. It is the impact rod only. And now if I'm right, according to Lenz's law, the direction of induced current should be such that it should oppose the cause. What is the cause? What is the cause? The velocity. So there should be force opposite to it. You apply again BL, left hand. So how the force will act in this direction. Now this force acting on the rod, now what it will do, it will make it to retard. This is at t equal to 0, this is at any time t. Now let's write the equation. Now we have I is equal to, so what is minus MA is equal to BIL. What is I is equal to? E by R. Oh, this is minus M dV by dt B dV by V is equal to B square L square MR dt. Now let me go for the integration. All this constant, BL, MR constant. So this is dt. What is the initial velocity given? U. At any instant of time, let V be the velocity. So V equal to U e to power of minus lambda t. So this is the speed of the rod at any time t. When do the rod will come to rest? After a long time. Let's is asking expression for the speed, then current I. We know I is equal to BLV by R. Look at the current. Is it a constant current? No, a variable current. And finally, what happened to rod? Rod will, after a long time, put t equal to infinity, the rod will come to rest. Then what happened? All the kinetic energy given to the rod, converted as heat, is available as heat in the resistor. So therefore, total heat generated in the resistor. There are two ways you can calculate that heat. Total heat generated H. One, you can go for I square R dt 0 to infinity, or directly shall I write initial kinetic energy given to the rod, because that only what will be converted into the eat that one. So let's assume this is a bulb. You project with a speed u. Then what will happen to intensity of bulb? I'll project the rod with a speed u. What will happen to intensity of the bulb? If there's a bulb, what will happen to intensity of the brightness of the bulb? Will gradually decrease, no? So so let instead of R, let this be a bulb. So these are the questions which are troublesome for you. In place of resistor, they'll give a bulb and this is a rail. The bulb will have the resistance and there's a rod PQ and these are rails. Huh? No, I'll ask you to plot brightness of the bulb as a function of time. Initially it will have brightness and it will gradually decrease. When the bulb will stop glowing at t equal to infinity. That's what the equation says. No, when current is zero at t equal to infinity. There's a question available in book like this. For exams, it will be of this kind. Application. What all you learned? Okay, how you manage, you know. So the bulb will have resistance R, no? So that R is can be ether coil, can be a bulb, can be any other circuit. Please do make notice of these kinds. Huh? First learn it and try to generalize. It'll be better for you. Okay, there's a very first problem. Almost every problem, the idea will be like this. So very simple. These are the what? The Lenz's law. Once you get the direction of induced current, the rest of everything is laws of motion. You should interpret with the help of the mathematics here. Okay, just see once. Shall we say now power? What is the role of BIL? Yesterday only I just discussed. Once again, let me focus here. What is the role of BIL?